Hi friends, welcome to the Tech Granth. Today we are going to solve the Leetcode problem, median of two sorted arrays. Do like, share and subscribe the channel for further update. So this problem is of type hard and the statement says that there are two sorted arrays num1, num2 of size m and n, and we need to find median of the two sorted arrays, and they have put a constraint that the overall runtime complexity should be in log of m plus n. So if this was not given, then the easiest approach would have been to use two pointer to both the arrays, merge the array and get the median. So median will be the midpoint of the array. So if the array is of length odd, like 1, 2, 3, the median will be 2. If it was of even length, like 1, 2, 3, 4, the median will be the mean of the mid 2 element. So it will be 3 plus 2 by 2, which is 2.5. So, but here it says that we have to do it in logarithmic complexity, so that solution may not be accepted by Leetcode and it will throw the error time exceeded kind of thing. And yeah, even in your interview, your interviewer may ask you about the complexity and he might tell you to better your complexity. Uh, so the solution for this, if we have to go it in logarithmic time frame, is little tricky, but once you get hold of the algorithm you will be able to code it very easily. So let's look at an example to understand how we can do it in logarithmic time complexity. So suppose we have two array 1 and array 2, both are of length 3, so it's 1, 2, 3, and so array 1 is 1, 2, 4, array 2 is 3, 5, 9, and we need to get the median of this sorted array. So median of sorted array will be, the sorted array will be 1, 2, 3, 4, 5 and 9 in this example. So if we have 1, 2, 4 and 3, 5, 9, so sorted array is 1, 2, 3, 4, 5, 9. So the median will be the mean of these two, 3 plus 4 by 2, which is 3.5. Okay, so how do we get it in logarithmic time complexity? What idea we will use is we will try to partition the array. So we will partition each of the array, we will pick one array, basically whichever is the smallest one. In this case both are of same size, so we can pick any of the array, and we will partition that array in a way so that number of elements on the left hand side and the number of elements on the right hand side are equal. Now when I say the number of elements on the left hand side and number of elements on the right hand side are equal, it does not mean that the number of elements of one array. What I mean is, when we suppose I partition this first array 1, 2, 3 at point 2, so left side of this array will be 1 and right side of this array will be 2 and 4. Now I have to choose the point in the second array to partition so that the number of element in when we join these two array, so in that when we join these two array, then the number of element on the left hand side of the joined array and number of element on the right of this merged array should be same. So suppose if I partition it at 2, so from the first array we get on the left hand side as 1 and right side will be 2, 4. So currently I have one element on left hand side from array 1 and two element on right hand side from array 1. Now from array 2 I have to give at least two element on the left hand side, so that we have three element on left hand side, total three element from left hand side, and total three element on right hand side also. So if I partition it like 1, 2, 4 and I partition it here, so suppose this is my barrier, so I have one element on left hand side and two element on right hand side here. So for the second array, I need to partition it in such a way so that I have two element here and then my partition and then the remaining one element. So if you see here, overall there are three element on the left hand side and three element on the right hand side, so they are equally divided. So this is how we need to partition. And once we partition both our array, then the element which is relevant to us is the one which lies next to the partition, basically. So the element of interest in our case will be these two elements. So I can just remove 3 also. So these are the element of interest to us, which lies on the left and which lies on the right of the partition. Okay, so here what I have tried is, suppose if we partition the first array at element 1 itself. So we have 3 elements on the right hand side of the partition from array 1. So when we choose array 2, that time we need to get at least 3 elements on the left hand side, so that they are balanced, so that number of element on the left and number of element on the right are equal. So here we have 1, 2, 4, and so we put 3, 5, 9. And since from the first array we don't have anything on the left hand side, we call it minus infinity, because this will be the minimum value of the whatever variable you are using. So if you are using integer, this can be integer dot min value. Same goes for here, since we don't have anything on the right hand side from array 2, so the value here will be plus infinity or an integer dot max value kind of thing. So once we have found this partition, like I told, the element of interest will be the ones which are just on the left of the partition and just on the right side of the partition. So what we need to check here is, if suppose this is the left of array 1, if this element is less than the right side of array 2, then we can say that everything on the left of array 1 of this partition is smaller than everything on the right of the array 2, because this is a sorted array, both the arrays are sorted. Same thing goes for the second one. If I can say that this element is less than this element, means the element on the left of array 2 from this partition is less than the element on the right from array 1, right of the partition from array 1, then everything on the left hand side is less than everything on the left hand side for array 2 also is less than everything on the right hand side of array 1. I hope I'm clear till this point. So if we don't find this condition true, like in this particular case, we have from array 1 we have integer dot min value, and on the right hand side of array 2 we have integer dot max value. So our condition says that in this value is less than this value, so we are good here. But if we see the second condition where we have 9 and 1, so 9 is not less than 1, so it means that the left side of array 2 is greater than the right side of array 1. So this is not the correct place to put our partition. Now from this we understand that the left hand side of array 1, the left hand side of array 1 is light weighted. Basically I need to move some element on the left hand side now. So I need to move my partition from here to some other point, maybe just after 1. So maybe I can put a partition like I was showing here. We have 1 here, and then 2, 4 here, and then I can put 3 here and do 5, 9 here. So if we consider this particular case, then again if we see 1 is less than 9, so it means everything on the left hand side is less than everything on the right hand side of array 2. But again this fails the test because 5 is greater than 2, so it means that still the left hand side of array 1 is light, and we need to move some more element across this. So we try this case. So we put 1 and 2 here and 4 on the right hand side of the partition. So we created partition here. Now if we test this case, so this fits perfectly because 2 is less than 5 and 3 is less than 4. So this is the right place to do our partition. Next, so we have got our partition. These 4 are the number which are of interest to us, and we need to calculate the median based on these 4 elements now. So there can be two possible case. One is the sum of the two array is even, like in this particular case it's 3 plus 3 6. So if you have a condition where the sum of the array is even, in that particular case what you need to do is you need to take the maximum from the left hand side, maximum element from the left hand side and minimum element from the right hand side, and take the mean of those two. Why we are doing maximum from left hand side and minimum from right hand side is because this element will be smaller than this element, okay, and this element will be greater than this element. So in a sorted array, if we consider these 4 elements 2 4 3 and 5, the sequence of these elements will be 2 3 4 and 5. So these two are coming from the left hand side, these two are coming from the right hand side. So the mean will be formed by these two number, which is maximum from the left hand side of the element, which is 3, and minimum from the right hand side of the partition, which is 4. So it is 3 plus 4 divided by 2. Now suppose the length of sum of the length of these two array was odd. So in that particular case, suppose we have one more element on the left hand side. So in that particular case, what we need to do is, there will be no element which will come from the left hand side. The answer has to come from right hand side. So it will be like the max of the, we are in this particular case, we are keeping one extra element on the left hand side. So answer will not come from your right hand side, it will come from your left hand side, and it will be the max value of the left hand side. So let me give you an example. So if we have, suppose array 1 has 1 2 4 7 and array 2 is 3 5 9. So my sorted array, so if I form a partition, I will form something like this to form a balanced partition, and here I will give 3 and here I will give 5 and 9. So when the sum of the length of the array is odd, so there will be one extra element, and we will put the extra element on the left hand side. So in this particular case, the answer will not come from the right hand side, because right hand side will be on the heavier side. So the answer will come from the left hand side. So what will be the answer when the sum of the array length is odd? In that particular case, it will be max of the left hand side of array 1 and of array 2. So this is equal to 4. So if I compute the sorted array from here, it will be 1 2 3 4 5 7 and 9. So clearly the mean here is 4. Okay. So now let me give you another example where we have a third criteria. So here in this particular case, we got the answer by partitioning it at this particular point. Now suppose we did not have find the solution in this case, then we would have partitioned it at some point here. So when we partition it on the fourth element, we will have 1 2 4 on the left hand side, and we will have 3 5 9. We will put the rest 3 element on the right hand side, so that left and right number of count matches. So in this particular case also, what will happen is, if you see, 4 is greater than 3, which is on the left hand side, and element on the left hand side is greater than an element on the right hand side. It means that our left smaller array, whichever is the working array for you, as working array will be the smaller array, the left hand side of the working array is small, is greater, is heavy basically. So we need to move one element of this on the right hand side, so that we achieve the balance. So we need to move this 4 on the right hand side here, and which will give us the solution like this. So basically this is a small sample, what happens when you have an odd array and what happens when you have an even array. So let us try to code for this. So once we have to code, we will check one thing. If nums1 dot length is greater, we will try to keep the first array as the smaller array basically. So if nums1 dot length is greater than nums2 dot length, we will not return, basically we will call this again and we'll reverse the order. nums1, okay, and after that we will simply get int x is equals to nums1 dot length int y is equals to nums2 dot length, and we will put something called int flow equal to 0, int height is equals to the smaller array size which is x here, and we'll say while low is less than equal to high. So once this is the condition, then we will we need to basically find the point where we need to do partition. So we'll say partition for x, we'll start from the midpoint. So we'll say okay, low plus high divided by 2, and we need to find the partition for y, which is the second array. So for the second array, the partition y will be we need to move equal number of elements on the left hand side, so it will be sum of the length of the two array. We'll add +1 to handle an odd number of case, so that we have an extra element. If the number is odd, I want to put an extra element on the left hand side, and minus the number of element I have put on the left hand side from our partition. So part y is x plus y plus 1 by 2 minus part x. Okay, so now I need to get int the left hand side max for first array. So for array x, for the first array, if I say, so the max on the left hand side will be if the partition that we got, part x, is equal to 0. It means that we don't have any other element on the left hand side. Basically this particular case, we don't have any element on the left hand side. So in this case we will say integer dot min value, otherwise we will say we need the value from nums1, and value will be this part x, basically wherever we have partition, minus 1. So it will be the last element, okay, and then we need to get int right minimum of x. So right minimum of x is, we need to find this element basically. So right minimum will be, if suppose part x, we need to consider this case where we have no element, basically this case we have no element on the right hand side. So if part x has reached its end, so value is equal to x, which is the length of the array, then I say integer dot max value, okay, otherwise it will be nums1 of part x. So this way we have got the left and right value from the first array. Similar thing we need to do for the second array. So I will say int left max y is equals to, if we have part y is equal to 0, then we have integer dot minimum value, and it will be nums2 of part y minus 1, and the max one. So the min value on the which is on the right hand side. Part y is equal to y, then in this case integer dot max value, otherwise nums2 of part y. Okay, so we have the boundary value now with us and we have the partition created with us. So what we need to check now is this condition, whether this left value is less than right value and this left value is less than right value. So we will say left max is less than or equal to the min y, and left max of y is less than equal to right max or right min of x. So if these two conditions are satisfied, then basically we have got the correct partition. So once we have the correct partition, we need to make a check that whether x plus y, which is the length of the array, if this is equal to 0, whether the length of the array that will come after merging the two array is even or odd. So if it is even, then what we will do is we will return, since they ask here double, the output type is double here, so I need to do double, and I need to add my formula. So formula will be mat dot max. So what we need to do is we need to take the max from the left hand side and min from the right hand side, take the sum of the two and divide it by 2, basically get the mean of that value. So I get max of this and this plus basically math dot min of the right hand side, which is this min value and this min value. So, and it will be divided by 2. So this will be the answer for the case where we have even length of the array. Otherwise, else again we need to get double. So now what we need to return is, if suppose it is an odd length, so it will be max of the left hand side. So this will be math dot max, and the value will come from whatever is the greater value on the left hand side. So I will take max from this. Okay, and if this condition is not satisfied, basically we have not got the correct value, then in that particular case what we can do is, if the left max is greater than, so we need to put else if left max is greater than right min, left max is greater than your left min, right? It's greater than left min. So basically left max is this one of x is greater than the min of this, which was this particular case. So I need to move this element towards right. So I just need to decrease my high partition. So high will be part x minus 1 else your low will be part x plus 1. So the else condition will be when you have a case like here where you have the left max of y which is greater than the right min of x. So in this case we need to move this one towards left. So basically we move the partition, this partition one step here. In this particular case we moved the partition one step towards left. So it was high minus 1 and this one is low plus 1. So this is the condition, and we are done, I think. Yeah, so if suppose we don't get any partition, so we'll just return 0 dot 0 here if we are not able to find the min. Ideally it should not reach here, but yes, it can. So let's submit this code and it is accepted. The runtime is 99.88% better than the other one, and it's very fast. So it's definitely the logarithmic complexity because of this partition that we created. So this partition, the approach we are taking is something like merge sort logic, where we start from the mid and go towards left or right. So that is the logic here. So that's it for the video. Bye.